Hello everyone and welcome back to our channel. Today we're diving into a powerful and easy to use function in PySpark, the substring function. If you have ever needed to extract parts of a string, such as getting the year from a date or isolating a specific identifier, then this video is for you. We'll explore how to use the substring function to make extracting pieces of data from strings quick and efficient. By the end of this video, you'll be able to easily apply Substring to your own projects and save time when working with text data. Introduction to the Substring function. The Substring function in PySpark is a powerful tool used to extract a specific part of a string from a column. This function is particularly useful when you need to retrieve a fixed length portion of a string, such as extracting a year from a date, a specific segment of an identifier, or any set of characters within a text. By defining the starting position and the length of the segment you want to extract, Substring allows you to create new columns that highlight the exact information you need, making it ideal for data transformation and preparation. For example, if you are working with a dataset containing dates in the format EA, MNDD, and you need to extract just the year, Substring provides a straightforward way to isolate the first four characters. Similarly, if you have product codes that have different segments representing different attributes, you can use Substring to extract specific parts of the code for analysis. By using the Substring function effectively, you can quickly transform your string data into a more usable form, making it easier to analyze and derive insights. This function is extremely useful when working with data that follows a specific pattern or structure, allowing you to segment and extract key information with precision. Whether you are processing text, identifiers, or dates, Substring helps make your data manipulation tasks more efficient and flexible. Basic syntax. The substring function in PySpark is used to extract a specific part of a string from a column by specifying the starting position and length of characters. To use it, you import substring from pyspark.sql.functions and apply it using the select method. You can give the extracted portion a new name using alias. The parameters include the column to extract from, starting position, using a 1 based index, and length number of characters to extract. For instance, if you want to extract the first 3 characters from a column, you set start post to 1 and length to 3. Using substring helps isolate and extract meaningful portions of strings, simplifying data transformation and preparation for further analysis. Why use substring function? The substring function is useful for extracting specific parts of strings, such as isolating the year from a date, pulling out the area code from a phone number, or extracting segments from identifiers. It helps in breaking down structured data into manageable components, making it easier to analyze. This function is often used for data transformation, cleaning, and reformatting. By using substring, you can isolate important information, format it for display, and make your data more organized and ready for analysis. It is a key tool in ensuring your string data is usable and well structured for reporting. Practical examples. 1. Extracting the first 3 characters of a string. In this example, we utilize the substring function to extract a meaningful portion of the product underscore code column in a PySpark data frame. The product underscore code column consists of alphanumeric product identifiers such as ABC12345, XYZ98765, and LMN54321. Each product code combines a prefix and a unique numeric identifier, and we are interested in isolating just the prefix of each code. To achieve this, we extract the first 3 characters from each string in the column, and we create a new column called code underscore prefix to store the extracted values. The substring function allows us to specify the column product underscore code from which to extract the substring. the starting position 1. Since PySpark uses a 1 based index, meaning the first character is at position 1, and the length of the segment we wish to extract 3 characters in this case. By using these parameters, we are able to create a new column that contains only the first 3 characters from each product code. The resulting data frame displays the code underscore prefix column alongside the extracted prefixes like a BC, ASAYS, and LMN. This operation is particularly helpful when working with codes that have embedded information within their structure. For instance, the prefixes may represent a product category, region, or department. By extracting them, we simplify the data frame and focus only on the information that is crucial for analysis. Such transformations are very useful in scenarios where you need to analyze trends based on certain parts of your product codes or when you want to aggregate data by these prefixes. This makes data handling much more efficient by allowing you to work only with the portions of the data that carry important meaning. Overall, using the substring function in this way helps transform the data into a format that is cleaner and easier to work with, making downstream analytics and reporting more insightful. To extracting a substring from the middle of a string. In this example, we are using the substring function to extract the last 5 characters from the product underscore code column in our PySpark data frame. The product underscore code column contains alphanumeric product identifiers such as ABC12345, XYZ98765, and LMN54321. We are interested in extracting a specific segment from each of these codes, specifically the numeric part, which starts from the fourth character in each code and has a length of 5 characters. The substring function is used to accomplish this by specifying 3 key parameters: the column from which we want to extract product underscore code, the starting position, which in this case is 4, meaning we start extraction from the fourth character, and the number of characters to extract 5. This allows us to create a new column named last underscore 5 underscore chars containing only the last 5 characters from each product underscore code. This operation is particularly useful when the structure of a string carries specific meanings or segments that are relevant to your analysis. For instance, the last 5 characters of these product codes might represent a unique identifier or contain information that differentiates individual items within a category. By extracting just these characters, we make it easier to focus on the core elements of the product codes that are needed for further processing or analysis. The resulting data frame displays the new column last underscore 5 underscore chars, which contains values like 12,345, 98,765, and 54321 from the original codes. By isolating these characters, we can gain insights into the data more effectively, such as performing aggregations or searching for specific patterns within the extracted segment. The substring function thus plays a key role in helping transform data into a simpler and more usable form, facilitating more detailed and meaningful data exploration and analysis. 3. Extracting substrings based on a dynamic position. In this example, we are working with a PySpark data frame that contains a column named product underscore code, which holds product identifiers in the format ABC1234, size is 5678, and LMN 9876. These product codes are made up of a prefix followed by a unique identifier separated by a hyphen. We want to extract the prefix, which consists of the first 3 characters before the hyphen. To accomplish this, we use the substring function to create a new column called prefix. The substring function allows us to extract the first 3 characters of each product code by specifying the starting position 1 and the length of the substring to extract 3. By doing this, we effectively isolate the prefix portion of each product code. The resulting data frame displays a new column named prefix that contains the extracted prefixes ABC, XIZ, and LMN. This kind of transformation is particularly helpful when the prefix represents a meaningful categorization such as a product type, region, or category. By isolating these prefixes, we make it easier to perform further analysis such as grouping products by category or summarizing data based on these segments. Using substring in this way not only simplifies the data but also allows us to focus on meaningful patterns and categories, ultimately making data exploration and reporting more insightful and manageable. It's an essential tool for transforming string data into a structured format that highlights important information and enables more effective analysis. 4. Using substring for date formatting. In this example, we are using the substring function to extract specific components year, month, and day from the date column in our PySpark data frame. The date column contains dates in the format EEM MDD such as 20231012, 2022, 2022, 20506, and 202402. We want to break each date into its individual components, the year, the month, and the day. To achieve this, we use the substring function three times, each time specifying the starting position and the length of the segment we want to extract. First, we extract the year using substring starting at position 1 and extracting 4 characters. This gives us the 4-digit year. Next, we extract the month by starting at position 6 and extracting 2 characters. Similarly, we extract the day by starting at position 9 and extracting 2 characters. Each extraction creates a new column year, month, and day in the resulting data frame. The resulting data frame displays these new columns, providing separate values for the year, month, and day for each date in the original date column. Breaking down dates into individual components is extremely useful when performing data analysis that requires grouping or filtering based on specific date parts. For example, you might want to analyze data on a monthly basis, or you might need to filter records for a particular year. By extracting year, month, and day, you can make the data more accessible for these kinds of operations. This type of transformation helps simplify the process of analyzing temporal data, making it easy to apply aggregations or to explore trends and patterns. By using substring, we make the data cleaner, more structured, and better suited for further analysis, enhancing our ability to extract meaningful insights from the data information. 5. Combining substring with other functions. In this example, we are working with a PySpark data frame containing a column name product underscore code. The goal is to create a new column by extracting the first three characters of each product code and appending a prefix to it. This is done by using the substring and concat functions in PySpark. First, we use the substring function to extract the first three characters from each value in the product underscore code column. This extraction is particularly useful when the first few characters represent a meaningful code or category that needs to be highlighted. Next, we use the concat function to add a fixed prefix code underscore to the extracted substring. The lit function is used to create a literal value, in this case code underscore, which is then concatenated with the extracted substring. The result is a new column named new underscore code that contains a combination of the prefix code underscore and the first three characters of each product code. For example, ABC 1234 would become code underscore ABC. The resulting data frame displays the new column, new underscore code, which helps create a more meaningful identifier by combining a consistent prefix with the key part of the original product code. This transformation is especially helpful when you need to standardize identifiers or create new labels for data, making it easier to categorize or sort through records. By combining a fixed prefix with extracted values, we ensure that the data is formatted in a way that is both meaningful and easy to interpret for downstream analysis, reporting, or integration into other systems. Such transformations can help to add context to data, making identifiers clearer and more informative, which is useful in organizing and understanding complex data sets. Thanks for sticking with us. Now you know how to use the substring function in PySpark to effortlessly extract meaningful parts of your data. Whether you're dealing with dates, identifiers, or formatted strings, this function can make your life so much easier. If you found this video helpful, make sure to give it a thumbs up and subscribe for more tutorials on PySpark and data analysis. Feel free to leave any questions or comments below. We'd love to help you on your data journey. See you in the next video.